First of all, let me express my thanks to organizers to invite me for such a great symposium, and especially when taking into account that I can speak about this topic, which is very attractive for me based on my scientific focus. So everybody knows that biological effects of bile acids are known for ages, but only last decade has brought increasing evidence that bile acids can exert also other metabolic effects other than classical detergent effects on lipids in the digestive system. And this was reflected also by medical and scientific associations and communities. And as you may see on this slide, the whole symposia were dedicated to this topic. On this slide, I would like to summarize what we know about biological effects of bile acids. We can subdivide them onto the effects on different levels. On the level of the whole organism, bile acids are responsible for elimination or homeostasis of cholesterol. On the level of the liver cell, they are responsible for cholaretic effects. We call it bile acid dependent bile flow. Those effects which are in blue color are those which are classical. Those effects which are in red color are those which are novel or emerging effects during the last years. And as you may see, there are effects of bile acids which are related to liver regeneration. They can regulate gene expressions via nuclear receptors acting as real endocrine molecules. And they obviously have effect on intermediary metabolism of macronutrients such as mostly lipids and saccharides. On the level of the biliary tract, they have effect on cholesterol and xenobiotics solubilization. They have antimicrobial effects. They can stimulate bicarbonate secretion by cholangiocytes. As you know, there are studies with nor-urso and bis-nor-ursodeoxycholic acid for primary sclerosing cholangitis. There are also mitogenic effects on cholangiocytes. On the level of the small intestine, they are responsible for solubilization of dietary lipids. They again have antimicrobial effects. They regulate gene expression, again via nuclear receptors in elocytes. They are responsible for FGF19 secretion, which is a factor regulating bile acid synthesis in the liver. They are responsible for glucagon-like peptide 1 production via TGR5 receptor in the intestine. And on the level of the large intestine, they modulate electrolyte secretion. However, they can even have deleterious or harmful effects. We well know that people with low LDL cholesterol levels have low risk of atherosclerosis, but these people have higher biliary secretion of bile acids. They have higher production of secondary bile acids in the gut lumen, and these people have higher risk of colon cancer. They also have higher risk of other diseases such as cholesterol gallstone disease and some others. And bile acids can also act on the level of the brown adipose tissue. They can stimulate thermogenesis via thyroid hormone receptors and TGR5 again. So this is a picture showing how bile acids can act within the intestinal lumen, and as you may see, this is intestinal vilus, and here you can see two cells which are enterocyte. This cell is equipped with ASBT receptor or ileal bile acid transporter, responsible for transport of conjugated bile acids gut lumen into the interior of the cell. And as you may see, bile acids can stimulate FXR nuclear receptor. The second population of the cells in this compartment is enteroendocrine L cell, which is equipped with this receptor. I mentioned that it's a TGR5 receptor, which using a little bit complicated pathway leads to secretion of glucagon-like peptide 1. On this picture, you can see what are the metabolic effects of bile acids and which organs and tissues are the targets for bile acids. And I've already mentioned intestine and also liver tissue. In these squares, you can see all the receptors. Most of them are nuclear receptors, which are responsible for providing for exerting the effects of bile acids. And as you may see, these receptors are ubiquitous. They are generally distributed within the whole organism. And we have these receptors in the cardiovascular system. I will mention it in my further slides in more detail. They are also in thyroid gland. I also mentioned that in adipose tissue, in pancreas, and also in some other organs which are not related to this topic. So how bile acids can act as metabolic regulators. So they can really influence, they can really affect the metabolism of lipids, glucose, and by this regulate energy homeostasis. You may see all these receptors. Again, I want to emphasize that by knowing that bile acids act via these receptors, they act really as hormones, as endocrine molecules. And here again, you can see many target tissue, many target organs which are influenced by bile acids. This is a cardiovascular system, and let's look at how bile acids can act on cardiovascular system. So they can influence cardiomyocyte, they can affect the functions of vascular endothelial cells, also vascular smooth muscle cells, and also macrophages. And let's have a look on the cardiomyocyte. Bile acids can influence ionic transport. They can influence TGR5. Look that this receptor is also present at cardiomyocyte cell membrane. They can influence FXR. Again, FXR is present in cardiomyocyte. They can influence muscarinic receptors, rather surprising fact. They can also influence adrenergic receptors, such as beta adrenergic receptors. And all this is summarized in this nice review paper. Look at this, how bile acids can act as muscarinic receptors modulators. As you may see here, there is a molecular mimicry, molecular similarity between acetylcholine and litocholic acid conjugated with taurine, and this is believed to be the reason why these molecules can act on the same receptor. What we know from the clinical medicine, what is the clinical evidence? We know that patients with cardiovascular diseases have low bile acid secretion, as described in several papers by these Israel authors. Bile acids can also affect individual atherogenic factors. They can affect dyslipidemia, acting via FXR modulation in the liver tissue. They can also influence inflammation, acting via TGR5 modulation on the level of macrophages. They can even inhibit platelet activation an aggregation by FXR modulation. It seems that bile acids can really, the metabolism of bile acids can really be a therapeutic target or a novel therapeutic approach for these diseases. And here I summarize how bile acid metabolism could be influenced using either bile acids per se or bile acid sequestrants. We know how cholestyramine can influence many metabolic parameters. We can even use these more sophisticated drugs such as intestinal bile acid reuptake inhibitors. Even so old drugs such as metformin can act as a bile acid metabolism modulator. We know that even metformin is capable of inducing GLP-1 secretion. It also influences reabsorption of conjugated bile acid in the ileum. We also know that some natural products exert some bile acid modulating activities. Of course, probiotics is a big topic, especially those probiotics capable of modulating bile acid metabolism within the intestinal lumen. Obviously, we have on the market first synthetic bile acid mimetics, and it was also mentioned in the previous talks that there are some other drugs, such as, for example, aramhol, which is a fatty acid bile acid conjugate, which is also used for treatment of NASH. So this is just a picture showing how the scaffold, steroidal scaffold of bile acids can be used as a tool to develop novel drugs to modulate all these nucleoreceptors with the aim to treat metabolic diseases. This is an example how natural products can influence nucleoreceptors responsible for these metabolic effects. This is olanolic acid from the olive tree leaves. And as you may see, there are real scientific data showing that these products can really have metabolic effects. And the same is true also for this acid, which is called betulinic acid, coming from the birch tree bark. And again, we have research data showing that these natural products can have a real effect on modulating metabolic diseases. So, because the only widely used bile acid modulator or bile acid per se is ursodeoxycholic acid, the question is whether this acid can be atheroprotective. There is a pile of evidence. Some of this evidence come from the preclinical animal studies. Some of them are from the clinical studies, from clinical trials. We know that UDCA has anti-arrhythmogenic effect. This is based on ex vivo study, but we also know that also can be successfully used to treat intrahepatic cholestasis of pregnancy, having anti-arrhythmogenic effect as well. It can prevent ischemic reperfusion injury based on this animal study. It can even protect from cardiac rejection in transplant settings, again, animal study. It can improve peripheral blood flow in heart failure patients. So, and a few examples how UDCA, knowing and taking into account the fact that UDCA is not a good modulator of FXR and TGR5, it still was proved to have effects on glucose metabolism, as can be seen here in these animal studies. This is a clinical study showing that patients with NASH taking UDCA can benefit from this treatment, having smaller intima-medial thickness compared to those not treated with UDCA, having direct anti-atherogenic effect, of course. And surprisingly, UDCA can even stimulate secretion of incretins, again, knowing that, that UDCA is not TGR5 good agonist. And this is also an important paper showing that URSO can be chemically modified to improve their capabilities towards activation of some of these metabolic receptors. So we also know that, that hepatic enzymes are good independent markers of cardiovascular diseases. And in contrast with early beliefs that liver diseases are not usually associated with cardiovascular diseases, we know from the recent epidemiological trials that persons with elevations of ALT and or GGT, gamma-glutamyl transferase, have increased cardiovascular diseases. And it's not true only for ALT, but also for GGT. And what is important to emphasize is the fact that the prevalence of LFT elevations of liver function tests in general populations reach as high as number of 10 to 20%. It's also important to mention this old study published in Journal of Hepatology showing that URSO can decrease activities of gamma GT and aminotransferases without any huge effect on other parameters. But this indicates that this drug could also improve cardiovascular and overall morbidity and mortality, probably. But we are still waiting for further studies. There are a few examples of studies in which effects of UDCA on liver function test activities decrease was documented. There are many others. So to conclude, I'd like to summarize that there are no doubts about systemic effects of bile acids involving direct action on cardiovascular system, having important impact on metabolism of energy sources, on pathogenesis of obesity, diabetes, and other metabolic and hormonal diseases. And despite representing a promising therapeutic target, we are still at the beginning of our understanding how to use bile acids as possible therapeutics for cardiovascular diseases. Thank you for your attention.